Okay, last part of our discussion, we want to use tree diagrams to answer conditional probability questions. So we're back to our adult internet users example, and then whether or not they also do video sharing. So here's a tree diagram that's already set up, and we want to find out what the probability is that given an adult is a video user, what's the probability that they are between 18 and 29. All right, so we're going to take this tree diagram, we're going to find the values that are in orange, we're going to add them up, and then we're just going to use, as I've done here, I've outlined them. And again, this is a slide from a previous example. I'm going to take the this percentage here over the total percentage to find the percent of video sharing users, right, that are between 18 and 29. So I have 0.1890 are 18 to 29, 0.2295 out of the total are between 30 and 49, 0.0728 are 50 and older. And so out of this group then, so given that they're video sharers or video users, what percent of this group then is between 18 and 29? So we take this portion here over the total, and we're going to end up with 0.3847. So that's how you use a tree diagram to calculate conditional probabilities. All right, that brings us to our last homework problem, which is 5.3.7. And so we're going to go back to the study on internet media usage, and here's a tree diagram that you could have set up from the previous discussion already. And we want to find out what percent of youth who get good grades are heavy internet users. So you want to, again, multiply these totals together, add them up, and then take the heavy users, so in this area, who get good grades, over the total percent of students who get good grades. So given that a student gets good grades, what is the probability that they are a heavy internet user? All right, I think that's going to bring us to the end of our lengthy discussion. Oh, actually, one more thing. All right, so now we want to talk about finding conditional probabilities algebraically. And so we're going to take our conditional probability equation and we're going to rewrite it by dividing everything by the probability of A. So you get the probability of A and B divided by the probability of A is equal to the probability of B given A. All right, so if you want to find the conditional probabilities, you need to have two of these three in order to find out the third. So we want to find the probability of B given A, given that we have the numerator and denominator here. So let's take an example. At school, 60% of the students buy lunch, school lunch. Only 10% of the students buy lunch and dessert. What is the probability that a student who buys lunch also buys dessert? All right, so let's go through the problem together. Right, so at a school, 60% of the students buy a school lunch. So school lunch is probability of A. Only 10% of the students buy lunch and dessert. And I should probably say also buys, who buys lunch also buys dessert. So what's the probability that a student buys dessert given that they've already bought lunch? So I have probability of dessert given lunch, probability of lunch and dessert, and the probability of lunch here. So the probability of buying a lunch is 60%. Only 10% of the students buy lunch and dessert, A and B. That's your numerator. What's the probability that a student buys lunch, also buys dessert? It's going to be 0.1 over 0.6, or 1/6. So I can find the probability that a student buys dessert, given they bought lunch, is 1/6 using this setup, which is just a rewriting of the conditional probability equation. All right, so I think this is going to bring us to our last homework problem. So problem 5.3.8. At a clothing store, 75% of the customers buy pants. Only 20% of the customers buy pants and a belt. What is the probability that a customer who buys pants also buys a belt? All right, so please copy this down as we come to the end of the video. Thanks very much for joining. Lots of work to do, lots of information. Hope you got something from it. And again, please pause to write this down because I'm going to end the video.